Now, once in a while you're running and your program just stops. It dies in the middle for some reason and quits. And you go, oh, and I didn't get my output. Now, the reason you didn't get your output is it's collecting the output in a buffer. And when the buffer fills, then it actually sends that on to the operating system to print the buffer. So it's buffering the output. And that last buffer that has all the interesting stuff right before your program died is just gone. I mean, the program died. Now, there may be some ways with some debuggers to go get that, but the point is you didn't see it. And the way to get this so you see it is to flush the output. In C, there's a flush call in the standard C library. In C++, you can do it cout like this. And if you go in Google and you put in Python flush standard out, you can go find out that there's a flush for the output there. There are flush commands for pretty much every language that has output, because everybody has at some point faced the problem of the data is stuck in the buffer and I really need it to be sent and I need to wait. So knowing that there is a ability to flush things is important, and you can go get Google and get the exact syntax for whatever language you're working on. Now, this is kind of the debugging side of it. Print stuff out, print out your variables, see what's happening. You get a file. Sometimes you want to do nice things like add coloring to it. Sometimes there's ways to do that. That can help, but this is kind of the basic stuff. Now, most programs out there, in a server context certainly, they write log files. And there is a logging facility built into Windows. Okay? And I find it to be quite horrid because there's no search facility for it, and it doesn't send it to a file so that I can use some other tool like grep to go through it, or a VI to go dig through it and find stuff, because it's written in binary, and consequently, if you want to have a search facility, yes, you got to buy some special tool that the uses to go search it. And I never have the tool on the server that I'm working on, and yada, 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 yada. So I find it to be pretty horrid, but there is one. Now, in the land of Unix and Linux, okay, usually logging looks an awful lot more like a file, and you can use standard file tools like VI and grep to go searching through it. You can use things that in a script you can write to the log. I'll show you an example there in a second. But the question is, how do you get these standard system logs back? Some programs, NGIX writes to a log file of its own. It's stored over in /var/log. Apache. But if you have your own program or a lot of other programs, they write to the standard system log. And there are nice tools for taking system logs and consolidating them if you have multiple servers. But if you're logged into the server, either you're going to do log show on things like a BSD or a Mac system, or you're going to use dmessage, which will show the current set of log entries. I don't know if you remember this, but when we started on the stuff with VI, I actually went and edited a file that I said was generated as a log off of the system that I was working on. I used dmessage to get the log file, dumped it to a file. I was logged in with SSH, and then I used SCP to copy that from that server halfway around the world to my machine, and then I could use it as demos for the class. So getting that to where you can actually work on it is usually pretty easy. So, you're writing a shell script or you want something to go into the log. There is a command logger that you can run at the command line, and you could just say some message. Sometimes it's useful to just throw a message into the log file, like, oh, this is where I started fixing whatever it was on this system. So you can know that everything after that point in your log files belongs to your set of fixes, not something that was happening before. So sometimes it's just useful to just throw messages in. On BSD, Berkeley Standard Distribution-based Unix systems like Mac OS, it is a log show. And you'll notice I've added a last 1 million messages because usually, at least on my computer, they've been around for a while and I have a lot. So certainly the last 1 million will be quite enough, unless it's a really weird day. And in this case, I'm just grepping for hello. But it shows you that you can take this and you can get it in a file and you can start processing it. On Unix and Linux systems, journalctl is the other command, besides dmessage. And again, it is got the parameter of being able to send in how many you want. In this case, it is different than the log show. That 1M there is 1 minute ago, as in time. So it'll only give you the last 1 minute's worth of messages. So again, I'm grepping for hello. But you maybe need the last 2 weeks. Now, most Unix systems, most Linux systems also have log rotation, which is where periodically there is some process that comes along that says, okay, let's get the log files, let's make a copy of it, let's start a new log file, and let's take the old one and we'll compress it and save it for 7 log files or something like that. There's a configuration parameter somewhere. But if you go and look in Verilog and you poke around and you see some .gz file that looks like it should be the log, but it ends in .gz or .1.gz. These are gzip compressed older log files if you need to get back in time farther and go find it. And quite often it's really interesting to go through your system logs, like find out how many times your system is being attacked, or pull out all the IP addresses and take a look at where those IP addresses come from. IP addresses are not guaranteed to have a location, but I find that about 90% of my failed login attempts come from mainland China. So let's talk a little bit about debuggers. This is what I call the new school. It's not that new. They've been around for a long time. There are different debuggers for different languages. If you're doing Python, there's a thing called PDB, which I'm actually going to demonstrate. For C, Fortran, and C++ on Unix systems, GDB is really powerful. It's worth taking time to learn how to use GDB because it has the possibility of doing things like set a breakpoint, which is a place where you stop in your code, and instead of stopping from that breakpoint forward, save everything that gets changed in memory, so that later you can actually walk your program backwards and see what happened. That's always a good thing to be able to do. If you're using some compiler based on LLVM, which is the more modern C++ compiler, and there's a bunch of other languages that also work with LLVM, or you're working on a Macintosh in Xcode, it uses the LLVM backend. Then there is LLDB, a debugger. And it's quite good too, and has a lot of these capabilities also. If you're working in things like Java, there are nice debuggers for Java. If you're working on the Linux kernel, here's a scary one. There's a debugger called ADB. Almost nobody ever uses ADB except people writing device drivers or debugging the kernel itself, because ADB is truly dangerous. Instead of debugging a program, if you have root access, you can use ADB to debug a running kernel that you're using at that moment in time. You can see what's inside the kernel's memory space. You can change values inside the running kernel. So it is truly a scary thing when you can go edit what's in memory and is the program that you are running at that moment. So beware, but also be aware that it is really useful if you're going to build device drivers. You just gotta have it. So ADB is magical and dangerous and hard to use. Let's run PDB once. I think I have a program here. We used this demo once before. It just counts up some numbers. But let's actually go in and run Python with this program. And you'll notice that I've said the module I want to run is PDB. And I can single step through the program. See that there is a call. Okay. And I can go next. This is still inside the initialization of the program, but it tells you that it's in something called Bootstrap. Okay. I can also do something like We finally got to some of my code. The def for signal handler. And I think this shows you one of the difficulties in sitting here and running inside a debugger is, okay, I can do next, and now I can do print I, and I can find out that it's 0. I can do next, I can do print mx. It's 10. Print I, and I've noticed that I has become 1. So I can sit here and I can interactively run through one line at a time and poke through the code and find out what's going on. It's not the most intuitive process as far as I'm concerned, but it certainly has its advantages, provided that, you can have the time and attention span to walk through the code one line at a time. For complex algorithms, for simple pieces of code, for things that you're running that don't take millions of executions to get to, debuggers are a great thing. And they're interactive, and you can poke around and you can see what's going on. When I'm working on a server and I see that the server is having a problem 2 weeks later, and it served, on average 30 million customer requests per hour at peak on multiple machines. I have neither the attention nor the attention span nor the time to mess around with a debugger. It just doesn't work in that context. It's unusable. When I'm working with something that is a remote embedded system at some inconvenient location, like on another planet, for instance, okay, this is not the way to debug it. Believe me, you do not want to try to run a debugger from Earth that has the time of lag difference between here and Mars. That is not going to fly. But it has its applications, and it's some good applications, and it works well for certain things. For the Python debugger PDB, I put in a table here that kind of lists the commands. It doesn't have a huge number of them. I've probably left some stuff out. But this is kind of the set of commands, and most debuggers have this base set of commands where you can list where you are in the program, you can step forward. Okay, you can put in a breakpoint. People like to put in breakpoints. They want to say, okay, I want a breakpoint at such and such a line number. Now run the program until you get to the breakpoint. Then I'll start single stepping. And you can poke into what the variables are. Now, poking into what the variables are works well when they're simple variables and not so well when they're complex variables. If you have some sort of complicated data structure nested 3 deep, you're going to spend a lot of time poking into it and following things like pointers and stuff like that before you get some understanding of what the data structure is. And again, this kind of depends on what you have. If the data structure is small, it works great. If the data structure is really big, like say you wrote a graphics program and this is 7 layers of an image that have had 1,000 edits and is 20 megabytes of data, and you go to print it out, okay, this is not going to work well. You have to look at some other alternatives besides using a debugger. So it can be good, it can be bad. I've got a link in there for PDB if you're doing Python, but I've also listed out most of the other debuggers. Of all of them, the one that I like best is GDB. If you're writing C code and you want to become an expert at C and C++, that's the debugger to be familiar with and how to get it to work and work well. Now, all of these things have to do with, I want to get some output from my program, and here's an interactive way to do it. But there are also visualization tools that allow you to go poke into a program and look at what's inside the program. And I want to show you an example of a visualization tool.